What you see here is the formula that Rhonda used to calculate his partition points. And what I'm going to show here is that this is the exact same formula essentially as what the referee's formula is. The referee's formula just looks a little bit more simplified. And that's all I'm going to be doing here is trying to simplify this formula to verify that Rodney's formula and the referee's formula are algebraically equivalent. So the first thing I'm going to do here is, I noticed that I have two different formulas here, and I'm going to show them. So I have the one for x shown right here, and I have the one for y shown right here. These formulas are almost identical to each other with the exception that one has x's, the other one has y's. So, I'm going to be doing the exact same steps in both of these pieces. It's just that, I'm probably going to not explain it as thoroughly for the y's because I'm just doing the same thing as I'm doing for the x's. The other thing that's different is I'm going to have x's, y's instead of x's. The subscripts, the a's and b's, and where they're located are all going to be the same throughout. So, as you're going to see here, the first thing I'm going to do is I'm going to distribute this a over a plus b. And I do it for both of them. So when I go to the next, stage, I can see that I distributed the a over a plus b to the x2 minus x1. And I did the same thing with the y2 and the y1. I see in each portion now that I essentially have, several additions and subtractions occurring here, as well as several additions and subtractions occurring right here. So, again, I want to be able to carry through these additions and subtractions because oftentimes that's what's needed to be done in order to do what we call simplifying. So I'm going to need to have a common denominator for the two terms that are currently not written along with fractions. Okay, so what I'm seeing here is, this one here and this one here, I'm going to, get a common denominator along with it. Along with that, I'm going to use the fact that if I take a fraction like this, and what's kind of being treated as a whole number, just a regular integer whole number, then I can get the same result just by multiplying this to the numerator. So each one of these are going to get multiplied to their respective numerators. So I'm going to see that all in the next step. So the next step, I'm showing the multiplication of a plus b over a plus b. That's going to give me the same denominator for the x1 expression, but the a plus b being multiplied on top is also going to allow me to, essentially multiply by 1. So I'm not changing what the value of this would originally be. I also have to keep in mind as I do so that these are parentheses up here. And when I carry through this multiplication and this multiplication, I am going to have to distribute again. And as you can see, each one of these, x2, x1, y2, and y1, have all been placed in the numerator along with the a. So when I carry through the multiplication in the first terms of each of these groups, what I get is ax, like in the first one, I have ax1 plus bx1 over a plus b plus ax2 over a plus b minus ax1 over a plus b. And again, I have a very similar case for the y's. Since I now have common denominators in each one of my groups, namely, again, this one for my x-coordinate and this one for my y-coordinate, I can now carry through the additions and subtractions because I have that common denominator. And the way I usually do that, and the way we've always have been doing it, is once I get that common denominator, I just add the numerator or subtract. This is the same rule for addition and subtraction. So I always carry through all the additions and subtractions in the numerator, and I keep the common denominator. So when I carry through the additions and subtractions I see in each one of these groups, I end up with ax1 plus bx1 plus ax2 minus ax1 over a plus b. And for the y grouping, I end up with ay1 plus by1 plus ay2 minus ay1. Now notice, each of these groups now has the first term and the last term being such that, when I carry through the addition, or in this case subtraction, they would just cancel. So these two would cancel each other out, these two would cancel each other out. And as a result of that, I would end up with the following formula, which, as you can see, is the exact same formula that was used by the referees. And so this is basically a proof that the two formulas will always produce the same results, and therefore they are what we call algebraically equivalent. If you have any further questions, please feel free to contact your teacher. Have a good day, everybody.